Welcome back to The Explainer. Today we are setting the stage for a really intense dive into the hidden logistics of offshore multi-rig mega projects. We're going to look at what actually happens when you try to build multiple giant assets right next to each other, and we'll be specifically focusing on the Cat J jackup rig program. Honestly, if you think managing one mega project is a headache, just wait until you see the invisible forces that take over when you put two of them side by side.
I want to hook you immediately by putting you right there in the executive seat. Imagine you're the project director. You've got a multi-unit build happening in the yard, rig number one is falling behind schedule, and the pressure's on. So here's your classic, high-stakes, director-level judgment call. Do you surge every available resource onto rig number one to catch up? I want you to hold your answer, because the reality of what happens next will probably surprise you.
Let's start with the multi-rig trap. This is the problem that absolutely nobody puts in their project plan.
When you're managing a multi-unit build, everybody tends to focus on technical failures or weather delays as the major risks, right? But the absolute biggest risk to your schedule isn't steel, and it isn't the weather. It's human behavior. The undeniable truth of yard dynamics is that resources drift to the lead rig. In a multi-rigged program, workers, cranes, and supervisors simply do not stay where you assign them on the spreadsheet. They naturally, almost magnetically, drift toward whichever unit is in the most trouble. And because it's the first one out the gate, the loudest problem is always the lead unit. On the Cat J program, this is exactly what happened. Rig number one ended up consuming an excessive amount of time clearing these unexpected obstacles during its derrick erection. It was this agonizing stop-start process, and every single hour of that overrun quietly pulled crews, heavy lift cranes, and crucial supervision away from rig number two. The result? Rig number two's schedule just slid right. The follow-on unit slipped, and it wasn't because it had its own engineering or steel problems. It slipped strictly because it was second in the queue.
So moving on to the predictor, how do we actually spot the manpower leading indicator before it wreaks havoc?
We desperately need a tool here, a metric that executives and project managers can use to spot this exact resource drift in real time. We're looking for a leading indicator, not a lagging one. And that tool is the manpower ramp-up curve. It is arguably the most vital metric in your entire arsenal. You're just simply plotting your planned headcount against your actual headcount week by week. In offshore fabrication, this manpower curve predicts a project's sail-away date better than absolutely any other metric, drawing, or progress report sitting on your desk. The crucial takeaway is this absolute mathematical certainty. A manpower lag right now equals a flattened progress S-curve later. If your actual headcount is lagging behind the steep climb of your plan curve, your actual physical progress, your S-curve, is going to flatten out roughly 1 to 2 months later. And here is the truly terrifying part for any project manager. By the time you actually see that S-curve flatten, your window to recover the schedule is already completely gone.
That brings us to the welder bottleneck, which is really about isolating the true S-curve killer.
Let's dig a layer deeper here. When that ramp-up curve fails, what are you actually missing? Well, it's almost never a shortage of general labor. The absolute number one S-curve killer is a welder shortage. You can have all the steel, all the drawings, and all the scaffolding in the world ready to go, but if you don't have the people to actually fuse the metal, your project sits entirely still. And you definitely cannot just pull random people off the street to fix this problem. We're talking about highly specific, certified talent here. Specifically, welders holding 6E and 6G qualifications. You can't just hire these professionals at short notice, and you certainly cannot train them at short notice. The brutal reality of the market is that every single yard in the region is fiercely competing for this exact same, very limited pool of certified workers. It's a zero-sum game. When rig 1 steals them, rig 2 dies. To really anchor this abstract S-curve concept in reality, let's think about a brilliant restaurant analogy. Imagine a popular restaurant on a Friday night. The bookings flooding in, that's your project schedule. The kitchen itself is your active workforce. When the kitchen gets completely backed up, adding more tables out front or, in our world, pushing more drawings to the yard does not equal faster service. It just creates a much bigger bottleneck. You literally cannot fix a backed-up kitchen by taking more bookings. And you absolutely cannot fix an 8 p.m. dinner rush at 8 p.m. You fix the kitchen in the morning by mobilizing your workforce and hiring cooks long before the rush hits. Mobilize early, get those certified welders secured early, or you simply don't get to serve your customers.
Okay, so let's look at the prevention, method change, and ring fencing.
We've diagnosed the illness, so how do we resolve this tension? Well, saving rig number 2 wasn't about yelling louder at the foreman or demanding a change of effort.
Brute force just doesn't work when massive cranes are physically blocking each other. The mitigation required fundamentally changing the geometry of the build. We're talking about a total change of method. And the scale of this solution was absolutely massive. To completely bypass the crane coverage problem that caused all those stop-start delays on Rig 1, the team deployed an 800-ton Goliath gantry crane running on heavy rails. Let's look at exactly how this mitigation works, because it's a real game changer. This Goliath crane straddles the entire build area on rails, providing full, uninterrupted coverage of the erection zone. It completely eliminates the crane clashes and stop-start obstacles that plagued the first unit. We are talking about executing the exact same scope of work, but with significantly better geometry, resulting in a much faster erection. You aren't changing what you are building at all. You are fundamentally changing how you lift it. So, let's bring this narrative full circle back to our opening hook. You're back in the director's chair. Rig number 1 is late. Now that you're armed with all this data on resource drift, flattened S-curves, and welder bottlenecks, let's ask the question again. Do you surge every available resource onto rig number 1?
Here is the definitive executive answer. Yes, but only if you ring-fence rig number 2's core crew first. You absolutely must protect the follow-on unit. If you strip rig 2 of its 6G welders and its heavy lift support just to save rig 1, you aren't going to recover a single unit. Instead, you'll convert a single late asset into a completely late, entirely derailed program.
I really want you to remember this quote, because it is the golden rule of offshore fabrication. Protecting the follow-on unit is not optional generosity. It's how you stop one problem becoming 3. Ring fencing isn't about being nice to the Rig 2 team. It is cold, hard risk management.
So, look at your own projects right now. Are you using tools like the Manpower ramp-up curve to actually predict your project's future? Or are you just waiting around for the S-curve to flatten out, essentially reading its history when it's way too late to act? Go check your Manpower curves today. Make sure you ring-fence your critical resources early. Thank you so much for joining me for this explainer, and keep building smarter.